In my previous video, I discussed how to compute risk and return for two securities portfolio. Today, I am going to discuss a special case for risk reduction. Earlier I discussed through empirical data that the risk could be even reduced to zero when the correlation coefficient between the returns of the two securities is -1. Here today I am going to discuss that case where the risk for two securities portfolio would be reduced to zero, and at the same time I will discuss how to compute the weightage or proportion of investment to that portfolio for reduction of risk to zero. How? That I am going to discuss. First, this is the formula for computation of risks, which I have already discussed. Our topic is finding the proportional weightage of mix for zero risk portfolio in the case of two securities portfolio, when the correlation coefficient between the returns of securities is -1. So this is the formula for finding the risk for two securities portfolio, and where W1 plus W2 is equal to 1. Why? I have already discussed. So here is the special case where R12 is equal to -1. We have already discussed through empirical data that if the correlation coefficient is -1 between the two securities of a two securities portfolio, then risks can be reduced to 0 also. So with the help of this formula, now if we put the value of R12 is equal to -1, then this equation will be as follow, as this W1 square sigma only, this will be minus, because the value of R12 is equal to -1, and this is nothing but the square of this W1 W sigma 1 minus W2 sigma 2 square. If you break this, then you will get this. Now just eliminate the square, then you will get W1 sigma 1 W2 sigma. You just simplify it. Here I have put the value of W2 as 1 minus W1. The W1 sigma 1 minus, in place of W2 I have written 1 minus W1. Just simplify it, then you will get this expression. W1 is equal to this sigma 2 by sigma 1 plus sigma 2, and this is the proportion. If you mix to the two securities formula or two securities portfolio, then the risk will be reduced to 0. That is the purpose for discussion today. If W1 is computed with this expression as this, what will be the value of W2? W2 will be 1 minus W1. If this is say 35%, then definitely W2 will be 65%, because the total is 100%. And if in decimal form, if W1 value is 0.35, then definitely the value of W2 will be 0.65. Now we are going to check it through an example. Suppose this is the problem. Year-wise return for two companies are given. Company R and company S. This is the name of the company. The return of 2022 is 12%, and for 23 is 6% for company R. For company S, for the same year the return is this, and for 2020 the return is this. What you have to do? What is the expected return of portfolio made up by 60% of your total money to company R and the remaining 40% invest to company S. What will be the expected return first? Then find out the standard deviation for return of each company or each type of share of stock. This is the second. Third, what is the covariance? What is the covariance and coefficient of correlation between R and S? That is also you have to compute. You should know how to compute it, then only you can apply. That's why this type of problem is taken. Next, D, what is the portfolio risk of a portfolio made up of 60% of R and 40% of S? What we have shown for expected return. You have to find out the portfolio return also. Now come to the point E. Here is the main area of discussion today. Find out the portfolio mix for maximum reduction of risk and what would be the return for that mix. The question is, find out the portfolio mix for maximum possible reduction of risk and what would be the return for that mix. This is the problem and I will solve it. First, this is the answer part. I have solved it. Check. First, mean return for stock R and stock S. Mean means this year 12 plus 1830 divided by 2. This is the mean value. That is 15%. 15% is the average return for company R, return of stock. And for this company, yes, what is the average return or mean value? Stock is this plus this for 2 years figure 26 divided by 2, that is 13%. Now answer for the first question is expected return. This is W1 into 15% plus 0.4 into 13%. This is W2. You can compute the expected return will be 14.2% because W1 is 0.6, 60% is 0.6 and W2 is the 40%, that is 0.4, that's why W0.4 and the sum total W1 plus W2 is 100%. So this is the expected return. Answer for question A is 1. Now question B, standard deviation for each stock. Sigma R, this is the square root of, we know the formula for standard deviation, xi minus x bar square plus, similarly for the different years divided by n. The formula is sigma of xi minus x bar square divided by n and square root of it. That's why square root is the formula. You can simply use the square root. Xi minus x bar means 12 minus 15 square plus 18 minus 15 xi minus x bar square, total it and divided by n means 2 and square root it. If you do square root, then you get 3. That means standard deviation for the returns of stock R is 3. You can check by using the statistical formula also. For standard deviation of S, similarly 14 minus 13 square plus 12 minus 13 square, this is the mean value, total it divided by 2 and then square root it. The standard deviation for the stock is 1. Now covariance. What is the formula for covariance? Covariance formula is sigma of xi minus x bar into yi minus y bar divided by n. In this case, not square. Xi minus x bar is this into yi minus y bar is this plus similarly for second year and divided by n. This is the covariance value. With the help of standard deviation and covariation, you can compute the correlation coefficient of R and S. Company R and S, returns of company R and S. Another formula is also available for finding out the correlation directly without computing the covariance, that I will discuss in separate video. The result will be same. The formula is covariance of RS divided by standard deviation for R. Standard deviation is the value is this. Question C part is over. Now portfolio risks. You have to compute portfolio risks for the weightage 0.6 W1 and 0.4 W2. Just you put all the values to the risk formula. To put the correlation value as -1. This is sigma 1, sigma 2 into sigma 1, sigma 2. Sorry, this is the weightage. Sigma 1 is this, sigma 2 is this, and you will get the risk is 1.4%. Now come to the point E. What would be the proportion of mixing to the portfolio so that the risks will be reduced to minimum? As the correlation coefficient between the return for the stocks R and S is -1, we have already learned earlier the risks could be reduced to 0. That we will check also. But what will be the proportion of mix-up? That is the question. The formula already I have shown in my previous page. This is the formula. W1 is equal to W sigma 2 divided by sigma 1 plus sigma 2. In this case R, say this is R. WR will be is equal to sigma S divided by sigma R plus sigma S. See, WR sigma S divided by sigma R plus sigma S, the value comes to this, that is 25% or 0.25. If WR is 0.25, then WS will be definitely 0.75, as WR plus WS is equal to 1. You can check also the risks will be reduced to 0. You put all these values instead of previous 60-40 percentage, 60% 40%, you put in this way, invest in the security at 25%, that is 0.25, and for security is 0.75 and put in the risk formula, then you will get 0. That means the risk will be reduced to 0. That is the advantage. That means you can reduce the risk even to 0 if you know this process. You have learned how to reduce it. And what would be the expected return for that mix up? In this case, you are mixing 25% of your money in security or stock of company R and 75% to other company, that is S. The expected return will be in this way 13.5%, W1 into R1 plus W2 into R2. So in this way you can find out the weightage, how you can reduce the risks even to 0. That means if in the exam all the values are given, that means for two stocks the standard deviation are given, and it is also mentioned that the correlation coefficient between the return between the stocks is -1, then you can find out the best mix up, that is the reduction of risk even to 0 by this process. In my next video I will discuss the different situations of the value of correlation coefficient. In that case, how we find out the risk? When the correlation value will be +1, in that case, when the correlation coefficient between the two stocks returns is 0 or +1, then how we find out the risk quickly. And also I will discuss the case to find out the risk best minimum reduction, that best reduction of risk means minimum risk when the correlation coefficient value will be any value that is possible. That I also discuss in my next video. Thank you. Thank you.